Okay, I'm really excited. Thank you for staying. I must have looked a bit worried today, though, because a colleague came by and said, "Don't worry, don't be nervous. Just imagine that you yourself are naked." With friends like that, you don't need any enemies, so thank you, Frederick. So Reactive Java EE, we're going to spend some time in the Java EE ecosystem. So why? I'm a strong believer in public service, so if some hipsters are going to talk about Spring Boot, somebody has to take the one on Java EE. So we're going to spend some time discussing what Reactive really is and how we can do it. Before we start, shortly about me. I'm working at Squeed. I'm a full-stack web developer. Moved up here from Blekinge about 8 years ago, so that's the main reason why this is held in English. Yeah. If you're a bit confused now, no, that's actually not me. That's my older brother, but he's way more photogenic than I am, and these slides seem to sell a lot better having my brother on them. So if you are in contact with organizers, don't tell them that that's not actually me. If you want to reach me, it's at OLB Petersson at Twitter, or you can mail me at olapetersson@squeed.com if you don't grab me after this presentation. That's shortly about me. Also, shortly about Squeed. We have talked a lot about Squeed tonight, and whatever I say, you don't believe me anyways, because they are the ones paying for the food I eat and the roof over my head. But have a look at the timeline, and also at our technical blog, where you can read about how you get gyras into the JBoss backlog, or even into the CDI spec backlog. Some amazing person managed to do that. So when I put this presentation together, I spoke to the more experienced ones, the ones who have done this a lot. So this is my first time here at JavaForum. And what they all said to me was that if this is your first time, don't do any live coding. Never do a live demo. And I took this to heart, of course. Was a bit bummed out, because I like code. I also really like music. So I had to take it as a sign when I went home that evening and started to listening on Queen. And I heard Freddie Mercury sing to me, "The show must go wrong." So of course I built something. So this is a website. When I go to it, I go out to the Twitter API. I get tweets under the hashtag JavaForum. So this is live. If you want to join me, tweet under the hashtag JavaForum. Okay, so let's have a look at a common pattern. So I was going to ask you guys if you had ever seen a pattern like this, where you send in a request, and you are immediately just dispatching further down into your code, and you do something time-consuming, but you're still hogging the thread. And eventually this time-consuming thing returns, and you will return. Now I know that you have seen this, because it was in the microservices presentation. And what we usually do during this time is that we show a spinner. If this is an HTTP servlet, we grab an HTTP thread, we show a spinner to the user, and we wait for the time-consuming thing to happen, and then we return once we got it. So why do we do it like this? Why don't we do it more like this? So we grab a thread, we start to work on something else, and we don't block the thread while that something else is happening. We continue. Eventually, that something else will be finished, and then again, we of course have to read that response and or blocking, and then returning. So why am I telling you this? Well, if you have worked a bit with asynchronous programming, this is basically asynchronous programming. And it's one of the very core fundamentals in reactive programming. So what really is reactive programming? It's a vague term. It's a buzzword, you can say. But some guys at TypeSafe, or sorry, Lightbend, has put together a Reactive Manifesto of what they think is reactive programming. So of course, this is a manifesto. This is not the truth, but we're going to visit and see what they say is reactive programming. So the goal of our applications is to be responsive. We want the users to get short feedback times or short return times, response times. And we want to support responsiveness in our app all the time. And to achieve this, we have to build elastic applications. And they could have said scalable here, but they didn't, because an elastic application grows when you have a hard resource or hard pressure on your system, but it can also shrink when you don't need all those resources. Reactive systems should also be resilient, very much what we saw previously. You should embrace the errors, return them if something gets wrong, notify the users that we are no longer handling your request, and avoid these kind of rippling effects where your whole application crashes just before you got an error somewhere down the path. And to support the whole scalability or elasticity, the resilience and the responsiveness, we should build it on a message-driven architecture. So instead of the case where we do a request and we get the response, we want events or messages to happen within our system which we can react on and eventually notify a consumer that something happened that you were interested in. Okay, so I'm a big fan of Reddit. Does everybody know Reddit? If you don't, check it out. It's an amazing website. It's basically other people browsing the internet for you. They have this concept of TLDR, which means too long didn't read. So if you thought that this was a bit too much, the TLDR of this is don't block, be responsive. So this is something that we take with us when we continue during this talk. But why? Why should we even care? Well, first off, the user experience that people are expecting today is a lot higher than it was 5 years ago. But also, during the last 5 or 10 years, the hardware has gone through amazing evolution. And even in my phone today, I have multiple cores with multiple threads. So to use our resources at a maximum effort, we want to build reactive applications. Okay, so how do we do this in the Java EE ecosystem? So we have JMS. JMS is the queues in Java. That's asynchronous and message-driven by default. We have the enterprise Java beans, where we have message-driven beans. We will have a look at them today. Asynchronous beans. Then we will have the CDI with events and observes. So all of this we will have a look at today. Then we will skip the JAX-RS and non-blocking I/O and synchronous servlet because I'm really fond of WebSockets. Okay. So they say responsive in the Reactive Manifesto. I say WebSocket. So a WebSocket is basically an HTTP request which gets handled and it requests an upgrade, and eventually you end up with an open socket between your consumer and your producer. So why is this good? Well, if we have a client connecting to a server, we now have a full duplex communication here. So we are no longer based, or we don't no longer need the client to request to the server because we have an open handle to the client. So we can push things out to the client. So we will soon have a look at some code in Java EE. I will show you in the browser the demo application I showed you before. And what I have done there previously is that I have created a JavaScript WebSocket. So I'm not going to go into the details here, but when I will write WebSocket in my browser, this has happened before as a true TV chef. Okay, so let's have a look at how you create a WebSocket in Java EE. So let me just create a WebSocket. So what we need to do to connect to a WebSocket is still that we need an endpoint, just like we do in our everyday REST interfaces. So let's annotate this class with server endpoint, which is the exposure of that. And we'll call this hello WebSocket. And what the WebSocket spec says that we should do is to handle 4 methods. So we should handle an onOpen method, where we are connecting to our clients, or where we will end up when they are connecting to us. And then we should handle an onMessage annotation. So that's when we get a message, how we react to that. And then we'll have onError and onClose. So when people are disconnecting from us, or if something went wrong. So let's have a look at the onOpen. So I'll create a standard method here, annotated with the @onOpen. And what it takes is a session, a JavaX WebSocket session. This session that connected to us, we can get an async remote. So this is the handle back to that client, and we can now send text back to them. So for now, we are just gonna say, you are connected. So now we can connect, but of course we also want to handle communication. So we want to implement the onMessage of the WebSocket. What the onMessage expects from you is a string, which is the message, and again, the session that sent this message to you. Again, we can take the session, we'll get the async remote, and we'll send back Pong. So let's have a look at how this looks. For some reason, while flight 10 is really slow, or it wasn't, I wanted to drink water. So I've done all this JavaScript in the background. What it does when it communicates with the WebSocket is that it will use the console log for now. So it says that you are connected, meaning that we ended up in the onOpen method. But now I have a connection open, and I can start to send things back to the server. Amazing. Ping pong. Okay, not that amazing. This is not even a request response pattern. This is a ping and a pong. But what I wanted to show you is that we have an open connection to the client, and we can talk back to the client through the server. So let's have a look at our WebSocket again and what we can do to make it a bit more interesting. So I will implement a set, and the set will hold sessions. We'll call this peers, and we'll make it a hash set of session. Session. So when a client connects to us, what we do is that we'll add that session to the peers. And whenever we get a message from any of the peers, we'll loop through all of the peers. Swedish, okay. And if the peer is not equal to the session, we'll take the peer's remote and send the message we received back to them. Okay, so I hope I didn't do this too fast, but when we are connecting, we are adding the peers to our set of sessions, and whenever we get a message, we'll loop through all the connected peers and we'll send the message back to them if we weren't the one sending the message. So what we basically just built let's get rid of that. Let's get rid of that. Is a chat client. So these are two incognito tabs in Chrome. They don't share any data or any connections in any way. They are completely unaware of each other. So whenever I send something to from one of the clients, we will end up in that send method and push it out to the rest of the connected peers. So it's maybe not the best chat application. I think you will have a really hard time selling this chat application, but it has the basic functionality. Okay, so that's WebSocket. I will use something similar to this in the continuance of my coding here today. But when you show new things like this, so WebSockets were introduced in Java EE 7, so 2 years ago. But people are always asking, well, can I use it? And since IE 10, and if you aren't supporting Opera Mini in your application, you can use this as long as you are on Java EE 7. And what's so nice, again, about WebSockets, well, now we can push things that are interesting to all connected clients to the clients. We are being responsive. But the Reactive Manifesto also says that we should be message-driven. And I say message-driven beans. So please take 5 seconds to appreciate this very nice GIF I found of another driving bean. I'm very happy with that one. Awesome. Okay. So a message-driven bean is a standard enterprise Java bean that gets triggered, or not a standard, it's a message-driven enterprise Java bean. But it gets triggered, it listens to queues, and whenever something is put on that queue, the message-driven bean gets triggered. So it uses a bit of the JMS API as well, but basically what I will show you here today is that I have set up a test queue, and I have a REST service that pushes messages onto this queue. Whenever we get a message on the queue, our MDB will automatically get triggered. And of course, we have injected our WebSocket. So something external happens to our system, something is put on a queue that we are interested in, and immediately we can react to this, and we can push this out to the client. So, message-driven bean. So a message-driven bean is, as I said, an enterprise Java bean. What it does is that it holds the annotation at message-driven, and this is mapped to my test queue. What I wanted to show you is that we can also have an activation config. I will briefly go through the different configurations you can do, but I just want to show you that you can configure this to behave as you would like to. And then I have my message-driven bean. I implement the message listener here because I use a JMS queue. And what it does is that when I get triggered by this message on the queue, is that I will go into the onMessage method. And I have injected my WebSockets, so I will take that message and I will send it out to all the connected peers. So, a message is put on the queue. The MDB gets triggered, and I use my injected WebSocket to push this message out directly to the client. So, what I also need to do before this is that I will need to actually disable my REST and init my WebSocket. Okay. There we have it. So at this point, we don't have any data for our clients. But what I will do is that I will go to my API. I will send a message. So this is the REST service that puts messages on the queue. And whatever I write here will immediately get pushed out to the client. So again, as a client here, I don't really care that something that I was interested in happened, or I care that something, but I didn't have to do anything. I didn't have to reload the page. So for instance, if you have a weather service or something like that, where you want to push out warnings to all your connected users, they will immediately get it on their page. So what else is nice about message-driven beans? Well, we are loosely coupling. So there is a producer somewhere that puts these messages. Of course, we have to follow some kind of contract, but we are loosely coupled to from their implementation of the producer. These are run asynchronously, so they can happen in parallel as well, and they are, of course, message-driven by default. Okay, this is the activation config property. I realize that you can't read anything of this, but what you can config is like a message filter, for example. If you're only interested in some messages on this queue, you can config how many sessions that can run in parallel of these MDBs, etc. Check it out. This is from the official Java EE website, so if you're interested, have a look there, because this is impossible. Okay, so now we can be message-driven from when other systems are producing something to us. But maybe we want to have the same benefits internally within our program. So entering event and observes. So this was introduced in CDI, so since Java EE 6, and what it basically is a publish-subscribe pattern, but for typed objects. So what do I mean by that? Well, if we have an event, a Java event, that one will be typed. In this example, it's my class, that's the type. And this will fire an event, symbolized by the gun there. And somewhere else in our application, we have an observer, which observes this same class. It could be one, it's a one in this picture, but it could be several as well. And all of these will get triggered when an event is fired. And again, I inject my WebSocket in the observer and we push it out to the clients. So, starting with the dummy scheduler. So I didn't have the time to build something else that provides a lot of data to me. So what I will do to emulate this is that I will put a schedule on this method. So every 15th second, we will land in this method. What I have done here is that I have injected an event, and this event is the Javax enterprise event. It's of type list status, which is basically all the tweets under the tag JavaForum. And in my method, whenever I get triggered, so each 15 seconds, I will get the tweets from Twitter, and I will fire this event. That's all I care for. At the same time, I have a listener here. And as you see, in my method head or my function head, I observe the same typed object. So list statuses, again, the tweets that are returned from the Twitter API. So this will get triggered whenever an event is fired of this type. We'll end up here, again, inject the WebSocket, and we'll go out and party with the clients. So, of course, this is the scariest part, because this is live. I will send a tweet here with JavaForum, and I will redeploy my application to start the scheduled bean. Okay, so we will have to wait for 15 seconds. I hope. And there we have it. So now I got tweets. And too bad the Twitter API used to be really, really slow, usually is. But if I send something else here under the same tweet, eventually when the Twitter API catches up with this, this will be pushed out to my application. So again, if I would have an application like this where I am interested in all the buzz around JavaForum, I don't want to sit and refresh the page all the time. I want to get it pushed back to me. So again, we are being responsive. And today the Twitter API is especially slow. Okay, I'll give it 10 more seconds, otherwise we'll continue. Ah, there we have it. Perfect timing. Okay, so what happened? Well, the Twitter API is really slow, so it's their fault that I'm not that responsive. But I didn't have to do anything, right? I just sat here and wait, and whenever my system got the knowledge that a new tweet is up there, I got notified. So what else is nice about this pattern? Well, again, when we are message-driven, or in this case, event-driven, we are loosely coupling the producer from the consumer or consumers. So again, it could be multiple. But when I started to investigate or research the CDI and events and observes, I was a bit surprised. Because my idea was that I'll do something in my main thread, I'll fire the event, and I don't really care what you do because I want to continue here. So I don't want to block, I want to be responsive. But CDI events are actually synchronous. So how do we solve this? Entering the @asynchronous tag. So this was also introduced in Java EE 6, I believe, EGB 3 point something. And what it does is that you put this on either class level, and that will make all of your methods run asynchronously. Or you put it on a specific method level, and that will make that method run asynchronously. And what you oblige to when you use this tag is that you are either doing or returning a void, or you are returning a future. So for the ones who were a bit observant, I had actually TV chefed this, so the @asynchronous tag was there on the method level. Okay, continuing. This is Java SE 8, so this will not be the Java EE ecosystem. So be smart, be like Bart, don't fight the future. So CompletableFuture, well, first of all, if you haven't worked with futures, what a future is that you say to something that, hey, do this for me. I don't care for it right now, but go away, do it, and I will get back to you in the future, and then I expect you to have a result for me. If you have worked with JavaScript frameworks, this is promises, basically. So CompletableFutures came with the big Java 8 Lambda update. It has a lot of support for asynchronous methods, and there are a lot of them in this API. They support Lambdas very well, and yeah, asynchronous programming. So let's have a look at CompletableFutures. So, how do you write a completable future? Well, first of all, you have to create a completable future. It could be typed, which it will be in my case. So I'm expecting the future to return me a string. And what a completable future, what we can use in that API is supply async, meaning that, hey, go away, do this in another thread. The supply async expects to get a supplier, and what a supplier is basically an anonymous inner function. And if you're up to date with your Java 8 syntax, we are providing a methodless anonymous inner function. So this function will be called, and then we'll say return hello. And this is a silly example, right? I'm just returning a string, but imagine that this could be something time-consuming. And we could go along here, and this would do its thing in its thread. So we could do as out, hello, and eventually we could do a testFuture.get. And at this point, we are blocking. So when we do the testFuture.get, we are saying that I'm going to stay here, and I'm going to block until you actually give me the string hello. But as I said, the CompletableFuture supports a lot of asynchronous things. They also have the get now, for instance, which will return you a default value if your future didn't manage to finish on time. So I have created an example. What I will show you is a completable test where I start two futures at the same time. What they both do is that they call a dummy thread sleeper. So all that does is that it sleeps the thread that you're currently on for 5 seconds, and then it returns a string back to you. So here you see I do the test.get and test.toGet. So here I'm blocking, waiting for them to finish. And then you know the drill. I inject my WebSocket and I push this back out to my client. In the meantime, in two separate threads, I will also start the old usual way. So we will initialize our first string through this dummy thread sleeper method. Then we will initialize our second string, and we'll return the first and the second, or both these results through the WebSocket. Okay. The funny thing about Twitter is that they have a cap on their API, so I should probably not ask them every 15 seconds. And now my Wi-Fi is slow again. Thank you. Okay, so you recognize this, and what I will call is the future. So what this does is to give this synchronous programming or the synchronous method a bit of advantage. We'll start that first. Then we'll start the completable or the asynchronous CompletableFuture method second. So they will run in parallel. So in about 5 seconds, we see that the async finished. And in about the double the time, the sync finished. So no magic, I just wanted to show you that it actually works. Okay, so now you take all of this and you go to work tomorrow. You start to annotate all of your methods with @asynchronous. You push in message-driven beans and WebSockets all over the place, and suddenly you will have threads everywhere. That means that it will explode everywhere. So there is no silver bullet. I think you have heard that before. Asynchronous programming is not a silver bullet either. Reactive programming and these concepts can help you to be more responsive if that's your need. But asynchronous programming will always be harder. It will be harder to debug. It will be harder to follow. So if you start to do asynchronous programming, make sure that you are doing your stress tests, your concurrency tests, and everything like this. And if you are interested in how to still be robust with asynchronous programming, check out this guy. So go back in time 2 hours. This guy had a great speech on the resilience of microservices, and a lot of those concepts you can implement internally in your application as well. Okay, I'm very soon will be finished and we will all go and drink beer. I want to say that you can become reactive today. So what Mani does is that they read this manifesto and then it's religion and you have to follow everything or nothing at all. That's not true. What you can do is that if you have something that's really critical, that takes a lot of time, make that method asynchronous. WebSockets, which I love, are great, but a lot of the enterprise, like JavaScript frameworks, like Angular, they have huge support for REST, and a lot of your code base today probably is REST. So make a pattern where you push with a WebSocket for your application to get through REST, and you will be more reactive. But of course, you should at least have one CompletableFuture in your code by tomorrow. Okay, I'm not gonna stand here much longer. I would love if you could give me some feedback on this talk. This is widr.se/OLA. There is a ranking 1 to 6. I would love it if everyone could just go in, at least give me a number. If you feel like you have something that you can say to me that will make me better as a presenter, please fill it in, but you don't have to. If you are interested in watching these slides again, they are at widr.se/OLB. And there you can find all of this. So the Reactive Manifesto, the Reactive Java EE, let me count the ways, where I stole the Java EE slide from. My GitHub and my presentations, which only holds this one. Okay, thank you.